Okay, today we're going to be talking about triangle classification, and what we do with triangle classification is we're basically going through what it means to talk about triangles by different characteristics that they have. And so the first characteristic that we're going to talk about is classifying them by angle measures. Okay, so we can classify them by angle measures. So what I'm going to do is I'm going to mark up this first one, and I'm going to say that when we classify triangles and we have nothing marked, so there's only 3 acute angles. So this one's going to be called an acute triangle, and its characteristics are it has 3 acute angles. And in the second one, part of what we're going to do here is I'm going to give you a little bit more info. And a triangle like this is going to be marked in 3 ways. It's going to have 3 distinct angle measures. Now they're all going to be the same, but they're marked as the same with these arcs. And so this is going to be called an equilateral triangle. And it's going to have 3 congruent angles. Okay, so those are the first 2. The next 2 are going to be just a little bit different, because in these next 2 they're also distinct angles, but they are going to be having something to do with just one of the angles. Okay, so in the first one it had 3 distinct angles. The second one they had 3 of the same angles, and so in this one we're going to have one 90-degree angle, which we're going to call a right triangle. Okay, and it's characterized by one right angle. Okay, the next one is called an obtuse triangle, and it's characterized by this angle here, because that's the obtuse angle. So it has one obtuse angle. Okay, so what we're going to do in the next exercise is we're going to spend some time actually looking at these and how we do it. So we're going to classify each triangle by its angle measures. So if we look at EHG, we are going to have something here that has a 60, a 30, so we know that the last one must be made up of, this must be a right angle, okay? And so if this is a right angle, then this must be a right triangle. Okay, because it's got a right angle there. And if we look at EFH, we know that this is a linear pair, so this has got to be 120 here. And so this has to be an obtuse triangle. The key to this is filling in the missing pieces using what we already have. And so since we already have some of the angle measures, I just filled in the rest of them, okay? So that's kind of how this works. The second order of triangle classification. The second way that we can classify triangles is by side lengths. Okay? And so what we're going to do in this first one is we're going to say that it has 3 congruent sides. And this is an equilateral triangle, just like up above. And what we know is that if it's equilateral, we can also call it equiangular, because if the angles are equal, then the sides are equal. If the sides are equal, then the angles have to be equal. Okay, so it has 3 congruent sides. This next one is going to have 2 congruent sides, but one of them that is not. So we're going to call this an isosceles. And it's characterized by 2 congruent sides. Okay? And this last one down here is called scalene. And just for effect, I'm going to mark the sides, just so you know. It has 3 sides that are not congruent, so it has no congruent sides. Okay? We learned how to classify them by angles, and we learned how to classify them by sides. So let's use this information that we just learned to talk about these triangles. Now, we're going to classify by side lengths, A, B, C. Well, if we look at A, B, C, we notice that these 2 sides are the same. Okay? So even though it may not look like it, ABC is equilateral. Okay? You can't judge the triangle by anything but what they say the side lengths are. You can't judge it by look, because if you judge it by look, the picture could be wrong, it could be skewed. So just look at what the angle measures and the side measures actually say. If we look at A, B, D, this side length here is going to be 20. So we have 20, 15, and 18. So this one's going to be scalene. Okay, it's a scalene triangle. And that's how this works. Okay, we can classify, and eventually this is what we're moving to. This is our big piece right here. We're going to use the triangle classification to find the side lengths. Okay, and so what we need to know about this figure is that these are marked. So they gave us that. So how do we use that information to find the side lengths? Well, what I'm going to do is I'm going to say, because these 2 are supposed to be the same, I'm going to set them equal to each other. Okay, so 4x minus 1.3 is equal to x plus 3.2. So I'm going to add 1.3 to this side, add it to the other side. 4x equals, and this is going to be 4.9, sorry, 4.5. And then what I'm going to do is I'm going to subtract x from both sides. So 3x is equal to 4.5. So x must equal 1.5. Now, to find the side lengths, here's what I'm going to do. I'm going to take that 1.5 here, and I'm going to put it in. And what I'm going to end up with is, I'm going to take 5 times that, so 5 plus 2.5, 7.5, minus 0.02 is going to give me 7.3 here for JL. And this is going to be 1.5 plus 3.2, which gives me 4.5. And here's my check. I've got 4x minus 1.3, so these 2 should be the same. So I'm going to say LK is equal to 4.5. Sorry, 4.7. My mistake. Should be 4.7. You're right. I heard you saying that. And this one ends up being 4.7 as well. Okay, so when I outline this, I'm going to say JL is equal to 7.3. LK is equal to 4.7. And JK is also equal to 4.7. This is an isosceles triangle, so 2 of the sides are the same. one more example. We're going to look at the second example here, and in the second example we notice that this is an equilateral triangle. So what I'm going to do is I'm just going to pick two of the sides and set them equal. And so I see that 3y minus 4 and 2y plus 3, there's only a difference of 1 between the y's, and so potentially I'm not even going to have to subtract, or when I subtract I'm not even going to end up dividing. So I'm going to pick those. So I'm going to say 3y minus 4 is equal to 2y plus 3. So I'll subtract 2y from both sides. Okay, so I've got y minus 4 is equal to 3. I'll add 4 to both sides. So I've got y is equal to 7. And what happens when I plug it in is I get 21 minus 4 would be 17. I've got 2 times y, which would be 14, plus 3 is 17. And I've got 5y, which would be 35, minus 18 is equal to 17. And because it's equilateral, that makes sense that all of them are the same. So that's my check right there, is to see if they're all the same. Okay, so what I did was I used these classifications to know that I can set these certain things equal to one another. It's a good situation. So when you're doing these problems, make sure you're using the definitions of the triangles to help you out with finding the angle measures and the side measures. Okay? We'll see you next time. Thanks for watching.